As we go into chapter 10 now, we're going to deal with what we call radical numbers. And radical numbers are numbers that are under the radical sign. This is called the radical sign. And the number that's underneath it is called the radicand. So that's the radicand. This is the radical sign. And usually in there we have a number. But when there is no number there, the number that goes there is a 2. And this number is referred to as the index number, the index number. So if there's no number there, the index number is 2. That's assumed. If not, you have to actually put the index number you want. Here it's a 3, here it's a 4. And again, with no index number, there are 2 there. And that's kind of critical as we go through some of these things. So remember, there is a number 2 there as an index number. Again, by convention, we don't write it. Now, what they're asking you to do here is to, with the radical sign, which is sometimes referred, if it's a 2, as the square root sign, that's an operation. They're asking you to take the square root, or the second root of 100. And what that is, a number times itself that equals 100. So the square root of 100 is 10. Now, when we are asked to take the square root of a variable with an exponent, and you remember this index number is 2, a way to do it is take this 2 and divide it into 14. And you get x to the 7th. Now, the instructions for this is they want to define the non-negative answer, square root or root. And if it's the square root, the non-negative one is 10. That's sometimes referred to as the principal square root, or the principal root. Now, when we get to example 2, the index number is 3. So this is the cube root. What number times itself, the exact same number, 3 times, gives you 125? And that is 5. And I have to get back to this negative sign in a minute. In fact, I better not leave it out. When there's a negative sign out in front of the radical sign, put that over there in the answer column. So that's going to be a negative 5. But there's not a negative under the radical sign. This one applies to everything because it's outside of the radical sign. Now, using that same little technique, we use our index number to divide into our exponent. So this is going to be divided by 3. This is going to be divided by 3. So this gives you then x to the 2nd, y to the 4th. So the cube root of this radicand is 5x squared y to the 4th, and then we apply the negative sign. But don't forget to apply it. Now, as we look at the 4th power, and we can think of our results as a fraction, 81 happens to be a perfect fourth, and you may not know that, but if you multiply 3 times 3 times 3 times 3, you get 81. And that's a perfect fourth. So the fourth root of 81 is 3. Now the fourth root of 16, which is also a perfect fourth, is 2 times 2 times 2 times 2. 16. And then here we can use that very same method. Divide the variable, the exponent on the variable, by the index number, and that gives you y to the second. So the use of the index number to do these with letters, it's a good hint. Now as we go to number 4, again the index number is 2, and what two numbers exactly the same multiplied give you a negative 64? Now as you think of that, you might say, well 8 times 8 is 64, but that's a positive 64. And a negative 8 times a negative 8 is 64, but that's a positive 64. So what we say when we see something like this, where it's an even index number, and there's a negative under the radical sign, we write no real number solution. So once again, under the radical sign, if it's an even index number, if you have a negative, the answer is no real number solution. Now as we look at number 5, here we see the quantity negative 4 raised to the second power. Now what is that? Well, that's a positive 16, isn't it? And the square root of 16 is 4. Now, sometimes they want you to think of possibly the non-negative or the negative possibility that a negative 4 times a negative 4 gives you a positive 16. And again, what they're asking here is square that, get the 16, and that equals 4. Every once in a while, they'll give you something like the square root of x, and they'll say, what's the value of that? And we know it's x, but how do we know if it was a negative x originally? Well, we don't know that, or a negative 4. And what we sometimes do is we'll put absolute value signs, knowing that when it comes out of the absolute value sign, it is positive. Okay, for something like this again, remember there's a 2 there. So we're just going to divide this by 2. This then becomes x plus 4 to the first power. 2 divided by 2 is 1. Or you can just write it without the parentheses and say that is your answer. As you do the practice on MathLab, they'll give you some hints. Says, oh, that's incorrect. And then they'll show you how specifically they want you to answer the example. In example 8, notice the index number is 3. It's odd. So it's okay to have a negative under the radical sign. So negative 27 is a perfect cube. So this is going to be a negative 3. And then we take our index number, divide it, x to the 4th. Now here you might note that the index number is 7. Again, divide the 7 by 7, which is a 1. So the answer to this one is going to be just the radicand, which is a negative 2. In number 10, again, it's an odd index number, so the negative sign is okay. This is a perfect 5th power, so that's going to be negative 2. And then, again, the index number is 5. This is going to be z to the 4th. Again, the index number is 5. This will be x to the 3rd. Again, we're just dividing that by 5. This is a perfect cube, so that's going to be 3. Divide this by 3 is x. Divide this by 3 is 2. Number 13 is a little interesting. I don't know if you remember this from an earlier chapter, but this is a perfect square trinomial that factors into its binomial x plus 3, the quantity squared. So when we take the square root of this, this just becomes x plus 3. Remember, the index number is 2. Dividing this by 2 gives you one of these. Okay, I set these last few up so it'd make it a little shorter. Here we're dealing with function. This is function notation, in which they're saying the function of x is such that the square root of 3x minus 2. And then they're giving you two values. For number 15, value 6. Number 16, value 9. This is the value for x. So what we do is we put the value for x under our radical as part of our radicand. So 3 times 6 is 18, minus 2 becomes the square root of 16. Square root of 16 is 4. So the answer for number 15 is 4. Then we put in a 9. 3 times 9 is 27. Minus 2 gives you the square root of 25. The square root of 25 is 5. So these are the answers. You use this function notation, insert the value for x where x is, and that's that. All right, in number 17, they're giving you a different function. This is cubed. So we're saying if you put 4 where the x is, we now have 4 minus 5 gives you the cube root of negative 1. That's okay, it's an odd number, and that is a negative 1. Then you put a 32 in where the x is. That's our 32. 32 minus 5 is the cube root of 27. And 27, cube root of 27 is 3. So there's 17 and 18, and that's how you would work it out. Now, for 19 and 20, they not only want you to do some things, but graph it. And they also want to know what is the domain of our x. Well, our domain of our x values here can be any value, just so long as when we put it under the radical sign, it doesn't make our radicand less than 0. So what number for x can replace x that would make this a 0? So you would just sort of like do this. X plus 1 equals 0. X equals -1. So our set of numbers that make this true for defining our domain is x is such that x is greater or equal to a -1. And the interval notation for that would be, you would start with a bracket at -1, comma, up to positive infinity. So your domain of your x values would have to start with a -1. If it was lower than that, it would make what is under the radical sign not a real number. So you then start putting values in here, and if it's a -1, -1 plus 1 is 0, square root of 0 is 0. If you put a 0 there, then 0 plus 1 is 1, the square root of 1 is 1. If you put a, I don't want to put a 4, I want to put a 3 there, that's better. So 3 plus 1 is 4, square root of 4 is 2. You want to keep your numbers so that you can plot them easy. And this one will be 8 then. So 8 plus 1 is 9, square root of 9 is 3. So you have some points and you plot those and that will give you the graph. For number 20, this is cubed. So they're wondering, what's the domain of x? Well, for x, since it's cubed, can they be negative numbers? Absolutely. So the domain for this one would be x is such, let me put that correctly here, x is such that x is any real number. So there's no exceptions there. And interval notation will be from -infinity to positive infinity. Now I've chosen some points to start the graph, and I've made these all perfect cubes. So if this is a -8, cube root of -8 is -2, -2 and -3 is a -5. This is a -1, cube root of -1 is -1, this is a -4. Cube root of 0 is 0, so this is a -3. Cube root of 1 is 1. 1 minus 3 is a -2. This is 2, this will be a -1. So you get a series of points, and then from that you build your graph. And good luck on this section.